Denmark, just north of Copenhagen. What we're playing on here is our new Lounge 2. This is our entry-level loudspeaker. It's just not made like the regular entry-level loudspeakers you'll see. These are handmade in Denmark. Even the cabinets are made in Denmark, and we build everything in-house from the ground up. Obviously, we do source the drivers from elsewhere, but we're using a highly customized tweeter from CS in these ones. Some of the features that we do in our design of speakers are quite different from the more conventional thinking. One of the things is that when we develop the speaker, the first thing we do is to ensure that we can get the perfect phase relationship between the drivers in order to integrate them to such a high degree that it cheats the ear. And we found that just minuscule timing differences between the drivers is enough for our hearing to tell the drivers apart, and that means that in most conventional designs where you kind of think of this down the line, you just never get that phase relationship as perfect as we want it to. So we start with that rather than taking it later, because if we can't get that right from the get-go, we just don't want to make the loudspeaker at all. So this is how we approach it. We approach it with the attention to timing and to phase integration as the get-go. In addition to that, one of the biggest problems in a replay chain is energy storage, because energy storage means that some of the acoustic power or the output is getting stored, and that means it gets delayed and then released, but not in the correct timing as the rest of the music. And this is something that can happen both electrically, in the electronics, in the cables, in the crossover, and mechanically as vibrations and energy, etc. So for instance, with these cabinets, they're very light. We use some bracing to stiffen them, but the idea is to think of the cabinet more like we think of a tone arm. So a tone arm, you want to be very stiff. You want it to be very, very responsive to what's happening with the needle. You don't want it to be as heavy as possible. You want it to be relatively light. It has to weigh something, but you want it to be stiff, and then you want to control the resonances. You also don't want to over-dampen it. We are thinking of the cabinet in the same terms, because the drivers are basically the inverse function of the cartridge. So we need the cabinet to keep the drivers in the right place, and then also contain the acoustic pressure that is being built up on the backside. So the way we approach it is to make a cabinet that is stiff, light, and where we disperse the resonances in such a way that they never become a problem. And then by not over-dampening and not adding unnecessary mass, we ensure that the vibrational energy is taken away from the drivers as fast as possible and not being stored in the cabinet. So it's a clever way of doing something that doesn't really add cost to the production. So this pair of speakers, we can sell those for a bit less than 3,000 euros a pair. But the engineering behind this is quite sophisticated and takes up lessons that we have learned from loudspeaker manufacturing for many, many, many years, some of which have been forgotten in the modern way of doing things. Also, the crossover is made so that it ensures that we get this phase relationship between the drivers that we want, but also that we don't have unnecessary energy storage in the crossover itself. In this model, which is our base model, we're using an inductor that we listen to a range of inductors to pick the right one. And the one we're using is a big air core inductor with a good amount of copper in it and no iron at all. And that means that it has much less distortion that you normally found in cheaper components. It also costs, I think, more than half than the woofer itself. You can't see it, but we know that we have to ensure that the signal integrity from the signal arrives at the terminals all the way through the crossover, through the cables to the drivers, and then also how the whole system behaves acoustically and mechanically. We have to preserve signal integrity from start to end. And that is how we approach the loudspeaker development. We do this to the same extent with our entry level as we do it with our high-end models. It's just a matter of, with more money, we can then spend more on components, but the design principles are exactly the same. So you want to hear some music? Yeah, proof is in the pudding, as they say.
Yeah.
Nico, you have some?
Yes.
Da